Hello, my name is Colbi Snider, and today we're going to be learning section 6.1, Basic Concepts of Fractions and Rational Numbers. So what are we learning in general? We're going to be learning fraction models, and fraction models have a bunch of different things you can do with them. You can do colored regions, fraction strips, or fraction circles. We're also going to be learning equivalent fractions and fractions written in simplest form, so you're going to make a fraction go to its lowest term. And also, we're going to be learning about how to change two different denominators to a common denominator so you can add or subtract. Okay? So, fraction models. Fraction models give a simple visual representation of a fraction as a whole. There are many different types, like I said. You have colored regions, fraction strips, or fraction circles. So I'm going to use three different types in these. So 4/5. If you're trying to represent 4/5 in a rectangle, say a rectangle or a strip, a fraction strip, you're going to draw a strip, and you're going to divide it into 5 sections. Okay? And so that's how much you divide it in is going to be your denominator, and you're going to shade your numerator. So you're going to shade 4 of the sections. So this strip right here represents 4/5. So the next one is going to be 5/8. So we're going to do a pie graph or a circle, a fraction circle to do that. So your denominator, you're going to divide it into 8 parts, a pie. And then your numerator, you're going to shade 5 of those. So 1, 2, 3, 4, and 5. So you're going to have 5/8. And then this one, we'll do another rectangle. You're going to divide it into 8 parts because that's your denominator. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Okay? And you're going to shade 1 of those. So that's just a little bit about fraction models. It makes it more of a visual to see, oh, I shaded 4 out of the 5. So my fraction is going to be 4/5. Okay? Next, we're going to talk about equivalent fractions. So a fraction that expresses the same quantity is going to be an equivalent fraction. Fractions may not have the same numerator or denominator, but can still be factored out to be equal. Okay? So 2/3, I'm gonna use the fraction strips to represent these and how all 3 of these are gonna be equal. So that's what we're getting to. All 3 of these fractions are gonna be equal. So the first one, you're gonna draw with your denominator 3 sections, and you're gonna shade 2 of those. With 4/6, 6 sections. But I'm going to show you how you can just do 3 sections and it's still equal to 2/3. So you're going to shade these and shade this, and I'm going to draw a dotted line. So 4/6, you have 1, 2, 3, 4, 5, 6 sections, and 4 of them are shaded. 1, 2, 3, 4. So with this, 4/6 still equals 2/3. Okay, 6/9. So we're still going to have 3 sections. Okay, we're still going to shade all 2 of these in. But this time, to break it up, we're going to do 2 dotted lines. So now, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 6 of those 9 are shaded. So that equals 6/9. And later we're going to get into making it simplest form or equivalent fractions, which this is, but 4 divided by 6 can reduce to 2/3. Okay, next we're going to talk about fractions in simplest form. Okay. So fraction shown in simplest form is done by taking a greater number for the numerator and the denominator and reducing it down to lowest terms. So a fraction is in its simplest form if A and B have no common denominator that's larger than 1, okay? And B has to be positive. So A over B, B has to be positive. Okay, keep that in mind. So 2 over 6. 2 over 6, you can divide each of those by 2 because it's a common factor. 2 divided by 2 is going to be 1, and 6 divided by 2 is going to be 3. So that's going to be how we get 1 over 3. You find what each of them can divide into, the multiples of them, and divide it. So 15 over 27, 15 and 27, their common multiple is going to be their greatest. You're going to divide by 3. It's going to be 3. So what times 3 equals 15? 5. 5 times 3 equals 15. And what times 3 equals 27? 9. 9 times 3 equals 27. So that's going to be how you get 15 over 27 to 5 over 9 in its lowest terms. So 4 over 6. 4 and 6, what do they have in common? 2. Divide by 2. Divide by 2. You're going to get 2. 4 divided by 2 is 2. 6 divided by 2 is 3. Or 2 times 2 is 4. And 3 times 2 is 6. Okay? Okay, next we're going to learn about common denominators. So fractions with the same denominator are said to be common denominators. In finding a common denominator, you first multiply the numerator and the denominator, and then find what both fractions can be multiplied by to reach the same denominator. So 5 over 8 and 7 over, I'm going to do it up here. 5 over 8 and 7 over 10. Okay? So 5 over 8, what you really want to do is multiply both of these. 5 over 8 times. So you're trying to get a common denominator between this and this. So then you're going to multiply it by 7. That equals, and 10. So you're going to take your numerator and denominator and multiply it by something else to get that. So, what times 8 is going to give you something that you can get over here? So that's going to be 10. So you can get 80. It's going to be the opposite. And then 5 times, hold on. I'm sorry. Yeah, you're going to multiply by both. So 50 over 80. Okay? And then you're going to multiply this by this denominator, this by 8, and you're going to get 56 over 80. So you have both common denominators. I just made that really complicated. We're going to do another example. So 5 over 6 and 1 over 4. So it's going to equal 5 times 6 times, and then equal 1 over 4. 1 times 1, 4 times something else, okay? So then you're going to multiply this denominator by this denominator. So 4 equals 24, and this denominator by this denominator, so 6. And that's going to be your common denominator. And then 5 times 4 is going to be 20, and 1 times 6 is going to be 6. So your common denominator is going to be 24. Okay? Lastly, we're going to talk about rational numbers. Any number that can be represented by a fraction or any number of its equivalent fractions is called a rational number. So example, 3 over 4 and 5 over 6. Since they're represented by a fraction and not negative or decimal, they're called rational. Okay, 5 over 6 is going to be rational. Okay, and they're whole numbers. So 10 over 15 and 2 over 3, and they're to their lowest term, they're going to be rational numbers. Okay? So that concludes 6.1, Basic Concepts of Fractions and Rational Numbers. Like I said, my name is Colbi Snider, and this is Math 232, Project 4. Thank you.